Okay, young ladies and gentlemen, good morning. To see you,
Good morning.
Good morning.
you came.
Good morning.
Morning. Thank you, thank you. My congratulations. You passed the first examination session successfully, and now you are uh, students in their full rights. You know what does it do now? You are able to improve your positions in the ratings, to understand what you need to be successful in university studies, and so on. How to enjoy. Now we begin studying our second course, which the title of it is Algorithms and Data Structures. It will consist of 13 lectures, 3 tutorials, and 5 labs. 5 labs. Uh, Lectures will be delivered by me. For now, it is in online mode. Whether it will be so until the end of the semester, nobody knows. Nobody knows. It depends on the situation with the pandemic. Um, Tutorials and labs in the number one will be, well, supervised by me, and in the groups 2, 3, and 4 and 5 by my assistant lecturer, Gleb Terещенко. Okay. At the end of the semester, there will be an exam. And I think that at the last lecture, we'll also arrange a test, as it was uh, with the uh, discrete mathematics course. But I will inform you specifically about the last lecture test. Test about if it will be arranged or will just pass directly to the course, because to the exam, because now we know what is the format of the exam and so on. That's why you don't need any additional training, just maybe there will be an exam for 40 points, and that's it. We'll see. We'll see. Now, now I'll show you the
Is everything okay?
no, just a moment.
Is
I'm trying
everything
to
okay?
switch. No,
Just
to
a
another.
moment.
I'm trying to switch to another. No.
Okay.
May I ask you, do you see
Okay.
all groups? May I ask you, do you see all groups? this page. Алгоритмы та структуры данных. Все 5 групп. Вы видите их или нет?
Да.
Ну и отлично. Вот here you have all the materials you require to study the course. So all now for 12 lectures, actually 13 lectures. The text for the lecture number 13 will be added. But here, this section of additional data, here I provided you with the course program, and here in this course program, there is a list of references, and you will find there the books that you can use additionally to the lectures that you have here. It, as usual, it is a full text files, Word files. You can copy and so on. So you have the tasks for 5 labs, and the tasks for 3 tutorials. You are supposed to read and prepare, especially for labs. Every lab includes the program that I give to you. You have to understand it and so on to such a degree that when I give, or the teacher gives you the task to design additional function or something to the class, you know what it is about. And you're supposed to actually complete it. And upload by the end of the lab. And after that, when you get maybe next time or during the consultation, it is also possible. I may ask you some questions about the solution, so that to make sure that you really know what is done here. Okay, so you are supposed to, and also for tutorials, you have to read before the tutorial, and to look through and think about the problems that are given there. And after that, maybe 2 or 3 will be given at the last half hour of the tutorial. You are supposed to provide a handwritten, or if you have enough skills, typed solution, and after that, to upload it, to get a mark. So that not to create huge lines, waiting lines. You are supposed to come prepared with the problems solved, at least try to solve, at least have an idea how to solve, and here programs prepared. You run it, you understand the logic, everything here in every. But here, by the way, here there is an unpleasant lab 5. I have here about, you will look at home by yourself, 30 or 35, I don't remember now, problems. And you have to write an algorithm by yourself during 4 hours of the lecture. It is like a test for your ability to write programs within the limits of this course. So you have, before when the come time, the time comes to the lab number 5 before, you better look through these problems, and because everybody will get individual problem here, and limited time. It will be difficult to how to say, to copy it from anywhere, to copy it from anywhere. Okay, now that's it. Here методичні вказівки до практичних занять. It is the title in Ukrainian as it is required, but it was written in English by me. Okay, and here some, well, I will return to it during the lecture. Object-oriented versus function-oriented programming. Just very, very general hints on a very, very simple example. Okay, introduction. Here.
А можно вопрос?
Да.
У вас в документах по лабораторным написано писать на C++, только на C++, или можно любой другой язык?
Что значит любой другой? А какой любой другой вы хотите?
Ну, например, C-Sharp.
Там C-Sharp можно. JavaScript можно. Но дело в том, что это должен быть объектно-ориентированный, так сказать, программа. Потому что мы будем реализовывать наши новые эти структуры данных в виде классов. Вот где
То есть можно любой объективно ориентированный язык, да?
Секундочку.
Хорошо.
Но я вам в каждой лабораторной работе и в каждой лекции даю полные программы на C++. Они инструкции я выбираю, ничего там специфического. Никаких специфических инструкций для C++ я не употребляю. Если A equal 5, это будет assignment, ну, присвоение, да, почти в любом языке. Там может быть в этом Паскале было точка, двоеточие и потом равно. А везде это равно. Итак, if это везде if else это везде if else. Поэтому я употребляю самые общие эти операторы в языке, и только там немножечко синтаксиса. Вот синтаксисом вы разберетесь вот из моего, так сказать, вводной лекции, я там чуть-чуть покажу на простом примере, а потом там же полный синтаксис, полной программы я вам даю в лекции. Совсем. Ее можно взять, скопировать и запустить, только если знать вот программную среду. Поэтому можно и другие языки, если они объектно-ориентированы, если там классы, и если вы там не будете пытаться применять какие-то специальные термины, специфические, в смысле инструкции, специфические для именно данного языка, непонятные для других программистов, пользователей других языков. Ну, а это здесь показаться, что такой ученый, знаю что-то такое, чего не знают другие. А вот все надо делать в этом курсе from scratch, с самого начала, пользуясь никакими там программами готовыми, например, взять готовую программу и для отыскания пересечения двух множеств. Ну, здесь это уже не будет, мы уже это делали. Но и здесь тоже нельзя. Если сортировать, так вы должны сами написать сортировку. Мы учимся использовать не, так сказать, библиотеки программ других языков, каких-то языков. А мы учимся фактически, как создавать такие библиотеки. Ну ладно. Так, ой, перебили меня, а вот здесь, сейчас, секундочку. Так, секундочку. Группы 3, 1, 2, 3. Вы видите topic zero introduction.
Да.
Да, есть.
Ну, хорошо. Тогда вот. Ну, хорошо. Я надеюсь, что все 5 групп видят topic zero. Значит, я уже сказал, в нашем курсе будет 26 часов лекций, 6 часов практики. О, sorry. Я вошел. I started to be agitated and started to talk Russian. Course structure, lectures, 26 hours, tutorials, 6 hours, labs, 20 hours, exam. This course aims, the task of this course is to improve your ability to design algorithms and computer programs. Course topics and references, the main thing, references, are listed in the course outline, in the course folder, in the section additional data. You'll find. I advise you to look carefully at reference number 2, which is the authors Дудar, Осыка, алгоритмы та структуры данных. Там все это, так сказать, на английском языке написано. Now we come to the stuff of the course. First, definition. If we are going to study the algorithms, then we have to just agree what do we mean by the term definition, algorithm. Informally, an algorithm is a sequence of exact, precise instructions that produces the problem solution for any legal input, which is allowed by the rules, by the, by the agreement, previous agreement, that this only such input data can be processed by this algorithm. So solution for any legal input after a finite number of steps. Definition. In computer science, a data structure is a data format. Data structure is a data format, method to present data. But here there are some data organization, management, and storage format. So format that deals with organization, management, and storage format that enables efficient access and modification of data, of course. A formal definition of data structure will be given a bit later. Now, selection of data structures and design of correct and effective algorithms are the most important stages in software design. So we always keep together data structures and algorithms because they mutually dependent. Nicholas Wirth, it is a famous computer scientist, wrote, algorithm plus data structures equals program. Meaning, that if the algorithm is fast, efficient, just takes little memory and so on, actually efficient algorithm, data structure is convenient for just modifying and accesses data, then the program is also effective, good, can be applied successfully. If something is here or here is, well, wrong, then the program is also, well, how to say, leaves much more to desire. You cannot develop an algorithm before you choose data structures to keep input, intermediate, and resulting data. First, you have to decide how you are going to represent this data. And only after that, you can design the steps of the algorithm that solves. Example that clarifies this, well, assertion, this statement. I want you to believe that it is true. Example, simplest problem. Given three integer numbers, A, B, and C, find the minimum number among these three. Solution 1. We use three separate variables, A, integer type, A. By the way, do you understand everything in this line? Is there anything which is obscure to you?
Everything is understandable.
Now we understand.
Great, great. But it is instructions from C and C++. So A is a variable of integer type. It is initialized by 5. B is also a variable initialized by 12. C is also a variable of integer type initialized by 3. Okay. After that, we check if A less than B. Do you understand this instruction? Everybody? Is there anything? Yes, I hope so. I hope so. Because it is common for all the languages. If A less than B, then A is the candidate to be the minimum, to have the minimum value. After that, we come here and check if it is true. We check if A is less than C, and if it is true, then A is the minimum. That is why we do this instruction. Well, those who did not study C, it's time to, it is from C++ instruction. It is for printing on the screen. Well, I can tell something more, that it is a object, stream object. This is a stream insertion operator, but just in general, approximately. This is for printing on the screen. And what is it? What does it do? What kind of data we have here? Here we have a string, min space equals space, and it prints exactly as it is between quotation marks. And after that, so this is one thing that is printed on in one line. And after that, here, the value of variable A is added to this string, also printed, the value. Okay, so here we just print min equal, and in this particular case, it is, no, but it doesn't print this. But if this is wrong, then it is C that has the smallest value. And if you just 5 here, 5 less than 12 true. After that, 5 less than 3, 5 less than 3 false. We come here, we don't have any option. Just min equal value of C, 3. Well, I will not continue just explanation like that, because I just wanted you to answer, to hear. I wanted to hear that somebody does not understand these notations, which is absolutely common for all languages. Okay. Else, it means that B was the candidate. We compare B to C, and if it is true, we print mean equal to B. Else, if it will print mean equal to C. Yes, one solution. Basically, we have just 1, 2, 3, 4, 5, 6 instructions. Well, and here. Solution 2. We store our input data in array. For these, we declare an integer a of 3 equal integer a of 3 equal, so 3 variables of integer type. Each variable has the name a and index. The first position 0, position 1, position 2. So the variables are numbered from 0 to 2. And this a number 0 gets the value 5, a number 1, 12, a number 2, 3. May I ask you, do you understand this notation about arrays? Is it something new to you?
No.
Yeah, we understand.
Great, great, I'm happy. Well, that's why everything that I'm going to give you in my programs should be clear. When it will be time to speak about pointers and so on, well, I will explain many times. After that, we declare mean, variable mean of integer type, and save there the value of a0. Actually, it is 5. And after that, starting the loop starts from position loop counter 1, 2, and 2 will be still less than 3, and 3 will produce false here. So j first, it is a j loop counter at the same time is used as a array index. A number 1, 12, less than mean 5. False. If false, we don't do this assignment. We just come here and j plus plus, it becomes j2, and it's saved. It is saved in variable j. 2 less than 3 true. We take the element number j. 12. Just a moment. Excuse me. Number j2, it is 3. 3, sorry. I was talking too long. Element number 2, the value is 3. 3 less than mean, and mean was 5. True. We save into mean these 3 and come here. J becomes 3. 3 less than 3 false. We skip it. And after that, we print on the screen mean equal, we take the value of the variable mean. Yes, also solves the problem, this solution. Now we have a question. Which solution is preferable and why? And
На русском могу ответить?
Что? Да, давай.
Конечно, лучше второе решение, потому что оно подразумевает, что мы можем иметь любое количество элементов в массиве.
Совершенно верно. You are quite right. Because it's, first of all, it's logically clear and it can be modified to solve similar problems. For larger inputs, never mind whether it is 1000 or something. We just integer, just constant integer n equal 1000, here a of 1000, and after that somehow enter values of these 1000 variables either by random number generator or maybe from the keyboard if we are not lazy. Then We initialize, and after that it will solve. And there is no way to apply this method if else's, nested if else's, for the number of variables more than maybe 10 or something. Well, and to say nothing. So here, an appropriate choice of data structure to keep input data allows to design a simple and effective algorithm that can be modified. On the other hand, if you want to use some ready function in your program, you must declare data types or data structures required by the function, required by this function from the library, Okay. Now, every programming language has its own system of built-in data types and data structures. Here, as an example, I give you such a system of data types and the structures that were provided in C++. So first of all, we don't give them as a list. We classify them. On the present them as a tree, if you like. First, a group of simple data types, a group of structured data types or just structures, and pointers. And what is a pointer? Pointer, it is a variable that keeps or stores address of some other memory location. Well, I don't know if you studied pointers or not, but I will explain what do we mean and how we use them. Simple data structures. They are divided into predefined and user-defined. Predefined. It is integers, characters, float, double, and Boolean data types, Boolean data. Some of these data types can be provided with additional keywords. For example, short integer. It means that only 1 byte is used for this variable of short integer type. And that's why the maximum value is very limited, short, unsigned integer. It means that the sign bit, the very first bit in the 4 bytes that are given for integer numbers, normally at the present time, normally 4 bytes are given to keep integer number. It also keeps the value, not the sign, to increase the limits of the value. Okay, so this user-defined enumeration data type. It is a type of a set. If you did not study, we will not talk about it. If and when we need this data type, I will explain you the syntax and all other things. Now, structured array, of course, integer a of 10 or 100 of 100. Yes, it is one name for the collection of, or not collection, sequence of memory locations. Each location can keep one same data type. Structured. Also, there are structures. It is a collection of memory locations to keep possibly different data types. Here, all the data variables are of the same type, and here possibly different. Union. It is a structure, but where some fields may change the type, change the time, depending on the value of the flag that is within the union. After that, class, it is also a structured data type. We have functions there, we have data members there, and of course, structured files. Okay. These built-in data types and data structures are sufficient for constructing any algorithm. Sufficient. Sufficient. But they may be not suitable data tools for designing some specific algorithms. By the way, structured data types, where data objects consist of many data items, but we will be interested and will study mostly data structures, the data types where one item consists of different fields. But so this is sufficient, but not always suitable. For example, suppose a problem consists in finding the shortest route or path from point A to point B on a map. We solve this problem on a daily basis using GPS, and not only. For example, in the internet, when I send some message, for example, email, on some email address, maybe to another continent, then this message is divided into small packages, so that not to keep well, I will not go into the details here. So my message will pass through many routers, intermediate routers, and the task is to choose the shortest path in the internet. Maybe that will deliver it in the fastest possible time, or maybe for some other reasons, depending what do we mean by the a price we have to pay for choosing the route. Okay, so this is the problem. If we represent a map in computer memory by means of integer variables, character variables, float variables, and arrays, and some other built-in data types, then an algorithm, and so a computer program, becomes very large and difficult to understand. Because, if a map is represented in memory by a new user-defined graph data structure, then the algorithm becomes small in size and logically clear. It will be Dijkstra's algorithm. And we'll return to studying it again, and we'll see what are the underwater stones or obstacles, problems there. So in many cases, if we use built-in data types, large, difficult to understand, and difficult to find any bugs, difficult to adjust it for solving some similar problems, like Dijkstra algorithms. Well, it was just designed for solving some problems, and after that it was modified for routing the packages in the internet. So because it is simple and logically clear and uses a convenient data structure. So In many cases, we should introduce our own, or they say user-defined data structures like trees, stacks, views, lists, graphs, and etc. etc. So on. Definition. Now, we said that the task is to define and implement our own data types and structures. We have to know, and what do we mean by a data structure? A data type is a set of items, simple or structured, plus set of operations that act on these items. So a data type is two sets. Two sets. In order to understand better this definition, why a data type integers is two sets, let us consider the data type of integer numbers. And actually, a set of integer items plus set of operations. So, in this data type, of course, it is a data type, not a data structure, because one item, 0, or one, +1 or -1, it is just one piece of code, encoded 4 bytes and so on. Well, we don't just consider it as a structured data. We don't separate here any parts of it, or of the value. Item 0, +1, -1, +2, -2, +3, -3, and so on. We prefer this sequence to be infinite. Infinite. We want to be able to use any value that we need. Operations. That it is addition, subtraction, multiplication, division, modular, that provides the what? The remainder of integer division of integer numbers. Remainder of integer division. Here it is comparison, equal, gives true or false, not equal, true or false, less, also logical values is provided. And here assignment. And also operations implemented by standard library functions, like power of xy that raises x to the power of y. Of course, it is done for float numbers, but it can be applied, of course, to integer numbers also. Square root of x that extracts a square root from x, and others. So this is a list of operations. Typically, a user does not need to know more about integer data type. But a person who designs a computer system must take care of many other details related to integer data type and other data types also. So not just to say, I need this +1 and -1, let it be. There is no magic in it. Everything should be done by our brain and by means of a keyboard, and to make the computer execute these functions. Such person has to make decisions about, and now it is exactly 12 o'clock. People, do you mind if we make a 5 minutes break? Do
We
you?
don't mind.
Of course, without
Of course you do not. Okay, thank you. Let's have a break. Let's have a break. Okay, people, I'm here. A bit impatient. 30 seconds left, but I'm here. Okay, so we said yes, 2 sets. We just get an idea about these sets, but typically a user doesn't need to know more about integer data type, integer variables, integer values, and operations on them. But a person who designs a computer system must take care of many other details related to integer data type and other data types also. Such a person has to make decisions about representation of objects in computer memory. In computer memory, we can give 2 bytes to present an integer number, then the maximum integer value that we can keep in this use in this data type is 2 to the power 15 minus 1, which is 32,667. Well, not much, not many. Here we wanted to have it infinitely large values, but the implementation puts natural restrictions on the maximum and the minimum value. If 4 bytes are used to present an integer number, then the maximum positive value is 2 to the power 31 minus 1, and we don't calculate here. Also, a decision should be made about the machine code to represent integer numbers, because one's complement, two's complement, binary coded decimal code, access 3 code, etc. Different machine codes. By the way, may I ask you, were you in some course, subject, were you taught about numbers, binary number systems, how we transform from binary to, for example, decimal, from binary to octal and hexadecimal, and so on?
Да, на основах программирования было.
Что?
На основах
You know.
программирования.
But you have also to know that it is not these just simple binary codes that are used. It is not simple binary codes that are used to store data, positive and negative, and so on. Because people would like to minimize, for example, some operations like add item, subtract, add 2 numbers, subtract 2 numbers. They are done by hardware. And in order to use same hardware for performing different operations, they just transform the binary code into, for example, 1's complement or 2's complement. And in this case, which is quite simple done, zeros by unities are changed and so on. And unities by zeros. And after that, same algorithm and same electronic device can perform both operations, addition and subtraction, and maybe some others. That's why coding is used to simplify performing, designing algorithms for these operations. So, how to represent integer value? One thing. Implementation of operations. Here objects and here operations. Any operation can be performed by many different algorithms. Multiply, in many different procedures, for example, for multiplication. It is necessary to choose the most suitable algorithm for each operation. To choose or to design the most suitable algorithm. The same decisions should be made about any other data type built-in or user-defined at the stage of design of a given data type. So, same stages. First, define these sets. After that, decide how to represent in computer memory. And only after that, we can decide how to, to design the algorithm, or which algorithm to choose from the list of available options. Design of any data type goes through 3 stages. Specification of a set of items plus specification of a set of operations. This is first step. Normally this step is done by a manager of a team of system programmers who decides what kind of data structure we need for solving in our computer, in our new programming language, for example, or something that is tuned or sharpened for solving specific problems. Choice of representation of items in computer memory. This is for a system programmer. This is for manager. This is for programmer. Choice of implementation of operations for programmer. At the first stage, a data type is designed as an abstract data type. Abstract. What is abstract data type? It is, and in general, abstract. It is something that does not give unnecessary details. Abstract picture. Abstract, we normally think about abstract pictures, paintings, and so on. But here, abstract data type, you will see definition. An abstract data type, ADT, is a data type that is organized so that the specification of items and operations is separated from details about memory representation of items and implementation of operations. So at the level of an abstract data type, even a person who knows nothing about programming can just, formulate the task. What kind of data and what kind of operations I would like to have in my computer. Why not? In abstract data type, a specification of operation, of an operation. Because how to specify this set? Well, it's simple. We studied in discrete mathematics. Put here curly braces here, and that's it. We have an idea what kind of items here. Put here curly braces, and we have the list or set of operations. But what do we mean to specify an operation? And in an abstract data type, a specification of operation consists of the name of an operation, the name, the number of arguments and their types. This is important. The type of the result, of the operation, a precise description of what the operation does, without saying how the operation does its job. We say what to do without saying how. such a description can be done in terms of a precondition and postcondition. And I will give you the precondition. It is the statement that must be true about the data before the operation. And the postcondition that must be true about the data after execution of the operation. So I will give you some examples of specifying the job of the operation in terms of precondition and postcondition. Why? Because in many cases, international tests in programming and in test of knowledge in computer science, it describes the algorithm, what it does in terms of precondition and postcondition. If the author is somewhere from the United States, England, or something. In all built-in data types are given to us, to user programmers, as abstract data types, because we do not go into details of their representation and implementation. We just use these types, that's it. One of the aims of the course is to learn how to design our user-defined data types so that other programmers might use them as abstract data types, as if they are built-in data types. Just define write the type, write the object of this type, and go ahead. So now back to the course. Our task in this course is to implement our data structures in C++ or other language using object-oriented approach. With this approach, the method of a user-defined C++ class, the methods or functions, if you like, of a user-defined C++ class represent operations of an abstract data type. Data members of the class contain data items of our abstract data type. So, in this way, the process of moving from abstract data type, from general writing, without any details, to a new C++ data structure leads directly to the definition and implementation of a corresponding C++ class. So, from such a level to the level when you can write in your program integer a equals 7, in order to pass this way, we need to define somehow the class of integer numbers. The second part of this course is devoted to the study of some classic algorithms, their design and analysis methods. These algorithms are based on different data structures. Okay, so I was talking so long here for you to understand what we are going to study in this course. And also I gave you some important definitions. Do you have any questions, people? If not, I will close it and I will tell you, close it. Come here. people of all groups, do you see this topic 1, function-oriented versus object-oriented programming? Excuse me.
Yeah.
You do. That's why, though you studied, I will just briefly just make a very, very brief and maybe just not profound, but enough to understand the program that will follow. In function-oriented approach, the program looks like this. The first, we must have the main function. Execution of the program begins of the program consists of several functions. Execution starts from the main. Look here. Look here. What is it? What is it that we are doing here? We explain the meaning of the name x1. It is not a keyword of the language. It is a name, and we explain it. If it is preceded, if the keyword of type is before this, then it is declaration of a variable, and after that of integer type, and we save 5 here. So here the name is explained. The name is explained here of integer type, and also here. R1, it is a name, and it is explained to the computer system, to the compiler, that first you have to allocate memory for keeping integer value, and right here, just when execution begins, we write 5 here. So explain here the meaning of the name, but F1, it is also a name. But before using a name, we must explain it, give the definition to this name, to the compiler, and after that. So the explanation should be done before it is used. In our simple case, there are more cases, but we could put here the code of this function, here, the code before, the code of this function here, and after that, well, everything is known. We could do it like this. But for many reasons, often it is preferable to place before main just headers of functions, function header. And such headers are called function prototypes. Actually, what does it contain? The name of the function, brackets. Says that brackets say, pair of brackets says, but brackets say that this is a function, name of a function, that the function has 2 parameters divided by 1 comma, and first parameter of integer type, second of integer type, and the return type of integer. And this header allows for a compiler to analyze if everything is correct here or not. F1, it must be a function. Yes, a function. 2 brackets, yes. 2 parameters, yes. The type of the first parameter, integer, yes. The type of the second parameter, second, integer, yes. So, and this is used in the right part of the assignment operator. That's why it returns the value. And the value is assigned to integer variable. Yes, and the return value is integer. That's from formal point of view, everything is correct here. Compiler can go on. Okay, so this is for a compiler. And after that, somewhere else, maybe in the library, maybe after the main, we put here the brackets. Put here the brackets. Well, actually, if we want just to do only two operations, sum and multiply. If we are not interested, just to make it as simple as possible. It is function oriented. Function oriented. Object oriented. Main. Again, the program consists of several functions. No, actually, well, let it be several functions. Here you see again F1, F2, but only one parameter. Only one parameter. And here's something interesting, call of a function. Why not just F1? Why not just F1? We have only one object here, one A. Well, this A, okay. In object-oriented programming, first of all, we have to say to the program what kind of data we are going to use and what kind of operations are allowed for using with this data. In this particular case, we say that our data is only one integer number, 1. The second integer number will come to as a parameter in the function call, 1. On this, so this is data member or data member of the class. Here I describe the type, by the way, describe the type. And if I look at this line, it looks like the variable and looks like the name of the type. Well, so, but in object-oriented programming, the type is now called the class. This is the name of the class. And we say the data members that we have in this class and the methods or functions that can be applied for this class. Okay. Public means that any program, any function can use this name, F1, F2. Private or protected means that only the objects of this class, the functions from this list are allowed to use this X. It is for private. For protected, a bit more complicated, but I will not go into all these details because too much for now. When it comes to the polymorphism, to inheritance, I will remind you. And also you will also study in your object-oriented course. By the way, these two lines, take it for now as standard. You include them in any program. Include your string using namespace. Same thing with C program. Now, here, as you see, these are just headers or function prototypes. Why only one parameter? It will come in the call, and this, the second value for the multiplication is X. That is why. And what is simple integer? Simple integer, it is a special function. By the way, its name It is the same as a class name. Such a function is called constructor. The constructor is the function that puts initial values into the variables of the object. Look, here we have only one variable a of this class, But since the type is called the class, the variable is not a variable. It is called an object or instance of class simple integer. Because here we may have not one variable, many different variables and several different variables, maybe the array here. That's why not one variable, collection of variables, private variables. And the compiler, when it allocates memory to A, it allocates memory to these private variables of this A. It keeps the set of private variables for this object. Here, just one x. But we could put here comma, b, and put the initial value, for example, 15, c, initial value 20. So we could declare here several objects. And each of these objects, A, B, and C, they will get their own private variable, in this particular case, x of A, and this is why we say A calls the function f1, and f1 must use the private variable of A, and here add it to 7, and return the value. Same here, the object A calls the function f2, and f2 uses x of A plus this 7. So that's why we just each time say which private variables to use from where, because there are many x's here if we have several objects or several classes. That's why this is the reason for this syntax in object-oriented C++. But it is possible to have different syntaxes. The main thing just to specify the object that is making this call. And here again, we print the value of R1 and R2. Here, look, it says print on the screen. First print the value of R1. And look, I just don't want to say, but it is a very complicated program because R1, it has its type, 4 bytes. And in 4 bytes, we may have -5, plus 77, or 17,511. So very different values. And here it is printing as a sequence of characters. So you see what kind of complicated transformation is performed by this of course system program. It is a huge program. But for simplicity, we say just insert this value into the stream of values. This insert into the stream of values that decide which pixel on the screen should be black, should be white, should be gray, and so on. And the characters are printed in pixels also. So here it prints as a string. Here it prints the number, and here just says bring the cursor to the beginning of the new line. But here we just gave the headers. After that, we have to give the code for simple integer, for constructor. What it does, it says, take x of the object and put the value a. By the way, where is the call of simple integer? It is here. It is here. This line. In this line, we have the call of this simple integer. The syntax is different from here. Here a is calling. Here a is calling simple integer, and here L is calling f1. Here it doesn't return anything because it just takes this value and writes it inside a. It doesn't show it to anybody, just into x, So a into x. That's it. Initial value. Simple integer. We take the value of the parameter 7, add it to x, and it was 5, get 13, return 13, the return value replaces the call 13, we save 13 into ASM1. And here the same is here. That is why, basically, not a big deal to create simple object-oriented programs. Simple. If you know instructions of, for example, C++, C language. Of course, this syntax, it is true for C++, even for Java, which is quite close to C++ in the syntax, but well, it is a bit different. By the way, in the manual, data structures star algorithms star data structures. True. Why? Алгоритмы та структуры данных. Дулер и Осип. Там в приложении есть все эти программы на C++ и на следующие, так сказать, приложения. Те же самые программы точности на Java. Поэтому те, кто, так сказать, интересуется, могут посмотреть, как это делается. Но я буду давать все. But I'm going to give everything that you need in the lectures. Okay, people, do you have any questions? Почему я говорил так долго об этих простеньких вещах? Чтобы вы не говорили, ах, мы не знаем, ах, мы и не хотим знать, и всякое такое. А я говорю, что это не C++, а я говорю, что это простейшие операции x плюс y, x плюс a, которые есть в любом языке. Ну, есть return, может быть, кто-нибудь там где-нибудь в каком-то языке не return, а что-то по-другому. Так, вот, но, в общем-то, это общая символика для большинства языков. И ничего в этом такого нет, если эти инструкции писать, используя, универсальную нотацию. Все. Any questions, people?
It seems no.
Great. But what? We'll start. In hope that you will read. List abstract data type. Now, may I ask you if all five groups see this topic 2, list ADT? Is it so? Because, well,
Yeah.
you never be sure. That's why I ask. List abstract data type. So I hope you understand that list, it is going to be the new data structure. We will pretend some programming languages include this list as a data structure in their libraries, and some, how to say, facilities, some tools for manipulating lists. But we pretend that we don't have any and start designing this list data type from scratch. In many application programs, it is necessary to deal with all kinds of lists, such as all kinds of, lists, such as a list of universities in Concord, a list of students in section number 1 in data structures and algorithms, and another list, a list of books in a library, etc., etc. We do same things or operations with any kind of a list. We create an empty list, add items to a list, normally one by one, search a list for some data item, search list for some data item, delete some data item from a list, and some other operations. In many cases, it is desirable to have a new user-defined data structure, list, in order to manipulate lists conveniently. Okay, so I told you what do we mean by a list and so on. We continue. Definition. A list abstract data type is a set of lists, one set, plus set of operations to manipulate lists. So, two sets. Definition. A list is a sequence of data objects of the same type. I just insist that of same type. In some books they say, well, we may keep different types in the list, but well, they are just, they have no sense. For example, the planet of Mars, the a boy Bova, the book from the library. These are they could not be a list of items of the same list, because such a list would not have any sense. So, sequence of objects of the same type. Example: a list of names: Sally, Ali, Tom, Angela. It is names unsorted. A list 2 of numbers: 2, 4, 7, 25, 30, 20, 52 numbers. We see sorted in ascending order from small to larger. A list of subjects: Database, C++, logic design, English, unsorted. List of subjects unsorted because they are strings and not sorted. Note. The list and the array, because we may think that it can be treated as an array. A list and an array are different concepts, different notions. An array is a sequence of memory locations of the same type. Memory locations. A list is a sequence of data items. A list may be sorted stored in array. Some people say that array is a home for a list. We shall consider only unsorted lists for now and call them just lists. An unsorted list can be made sorted by applying a sorting method or by applying special add item operation. Okay, people, just the last definition. An unsorted list is an ordered collection of data items of the same type. Now that we understood that what are objects in this data type, it is necessary to specify operations in order to concentrate on the logic of operations. We shall consider only lists with the integer data items. Of course, here I showed you very different data items, but in order to process them in the same by the same function, we should make the functions somewhat complicated. That will make obscure the logic of the operation. That's why, in order to clarify the logic of the operation, we shall consider only lists with integer data items. People, well, we have only 1 minute left. Do you have questions?
Можно вопрос?
Да.
У нас же после топик 0 шла топик 1. Просто я на TL не могу найти.
Что?
У нас после топик 0 шло топик 1.
Ой, слушайте, они все подряд идут вот здесь, в том списке, в DA. Потому что я не везде здесь менял вот эти вот. Топик 0 introduction, если хотите, топик 1 it is object oriented versus function oriented.
Все, понял. Топик 1 это...
А здесь есть два. Не обращайте внимания вот на эти нумерации. Они, так сказать, подряд идут в DL-системе. Вот там вот оттуда берите.
Да, спасибо, я понял. Спасибо.
А еще, значит, к следующему разу, пожалуйста, попытайтесь вот это вот прочесть до конца, так, и, может быть, начало следующей лекции. Постарайтесь понять вот эти вот этот код, так. Ну, а потом я, так сказать, здесь на первом буду подробненько объяснять все это, чтобы потом уже C++ не вызывало этих затруднений. У нас уже сейчас ровно без 10 час. Вы не возражаете, если мы сейчас закончим? No, great answer.
No.
Yes, now I see you just agitated. Надеюсь, вы все зарегистрировались. Спасибо за внимание.
Of course.
Спасибо за внимание. До свидания. Bye-bye. Сейчас, если я буду опять все это... Вы видите мое лицо вот сейчас вот или нет? Нет. Ну и не надо. Ну хорошо, видите, и хорошо. Так, до свидания. Это не так важно видеть мое лицо. Главное, так сказать, услышать меня. Bye-bye.
До
See
свидания.
you next week. Bye.
До свидания.